Assalamualaikum and hi to everyone. Welcome back to my channel. Okay, in this video, we'll discuss about the TDM. This video is a continuous from the FDM and WDM. So in this video, we'll discuss about the TDM. TDM is referred to the time division multiplexing, and we use this technique only if we have the digital. No. So by using the TDM, we try to combine the several low rate channels or signal into one high rate signal or one high rate channels. We only can apply this technique when we have the data rate of the transmission medium is greater compared to the data rates that required by sending and receiving devices. In FDM, we talk about the bandwidth. In TDM, we talk about the data rate. Okay, we must make sure that the transmission that we have higher data rate. In FDM, has higher bandwidth. Okay, so that's the difference. So TDM is digital signal, and the process is quite similar like FDM. We have three digital signal that come from three devices, for example. So we have multiple signal that come from multiple devices. We use multiplexer in order to combine those signal, and then we transmit the signal, the combined signal, into a single link, a single transmission medium, and then at the receiver side we have the demultiplex, and it will separate again the signal into n channels. We have four. Let's say for this example, we have four. We multiplex together. So, and then we demultiplex, and then it will generate another four channel. So TDM, we have two type of TDM. We have synchronous, and we also have statistical TDM. In synchronous TDM, the data rate of the link is n times faster, and the unit duration is n times shorter. Okay, look at this example for the synchronous time division multiplexing or synchronous TDM. Okay, let's say we have three channels. We have A, B, and C. If we want to transmit those channels using the multiplexing technique, so the data rate for each input connection is 1 kilobit per second. So if one bit at a time is multiplexed, which refer to the unit in 1 bit, what is the duration of each input slot, each output slot, and each frame? Okay, you need to know the duration of each input slot, each output slot, and the frame. The duration of each frame. Okay, so you have this channel, this signal, so it will divide into three. One frame will have three components of A, B, and C. So this part will generate one frame. This part will generate another frame. This part will generate another frame. So those frames will travel through the single link, go to the receiver side. Okay, based on that situation, calculate the duration. We can answer like this one. Okay, the data rate of each connection is 1 kilobit per second. So that means the bit duration is 1 over 1000 second. You change 1 kilobit per second into second, so you will get 1000 second or 1 millisecond. 1 over 1000. Okay, the duration of the input time slot is 1 millisecond, same as the bit duration. Okay, this one is the data rate. For B, the duration of each output time slot is 1 over third, 1/3 of the input time slot, because we have three signal or three channels that we want to combine together. So this means that the duration of the output time slot is 1 over 3 millisecond. 1 over 3. 1/3. So 1 over 3 millisecond. That's what is the duration of each output time slot. Okay. For C, each frame carries 3 output time slot. So the duration of frame is 3 times 1 over 3, or 1 millisecond. The duration of a frame is the same as the duration of the input unit. Okay, next example. Okay, this figure shows that we use synchronous TDM. So in this TDM, a data stream for each input and one data stream for the output. So the unit of the data is 1 bit. You need to find the input bit duration, the output bit duration, and the output bit rate, as well as the output frame rate. Okay, you need to know the duration of bit for input, output, the bit rate, and the frame rate. So each channel we have 1 megabit per second. So we have 4 channel. So we have 4 input. Okay, this one create 1 frame. This one another frame. This one another frame. This one another frame. This one another frame, until you have 1 megabit per second of a bit data. So for A, to answer the A, the input bit duration is the inverse of the bit rate. The bit rate 1 megabit per second. So we have 1 over 1 megabit per second. So it's equal to 1 microsecond. The output bit duration is 1/4 of the input duration. 1/4, because we have the 4 channel. So 1 over 4 microsecond. For the C, the output bit rate is the inverse of the output bit duration, or 1 over 4, or 4 megabit per second. So this also can deduce from the fact that the output rate is 4 times as fast as any input rate. So the output rate equal 4 times 1 megabits per second. So it's equal to 4 megabit per second. And for D, the frame rate is always same as any input rate. So the frame rate is 1 megabit per second. 1 mega, we have total frame 1 megabit per second. So we have 1 million frames per second. So because we have sending 4 bit in each frame, we can verify that the result of the previous question by multiplying the frame rate by the number of bits per frame. So this is the process. Example, for synchronous, okay, you have signal and you have time in order to make sure the process is in the synchronization. So it will send frame 1, frame 2, frame 3 until end of the